Every cell in your body is constantly producing metabolic waste. Without continuous filtration, these toxins reach lethal levels in under a week. Each kidney weighs less than half a pound, yet together they receive 20% of the total blood volume pumped by your heart. This diagram illustrates the daily workload. Your kidneys filter the entire blood supply of your body over 40 times a day. Processing this volume at such a high frequency cannot be achieved through slow, passive chemistry. It requires brute physical force. The kidney's primary mechanism for rapid purification is extreme mechanical pressure. This creates a physical paradox. The pressure required to extract toxins and keep you alive is the same force that makes the organ vulnerable to failure. Protecting your kidneys requires managing them as a high-pressure mechanical plant. Raw, unfiltered blood enters the system through the heavy-duty renal artery. As this model shows, the primary artery subdivides into over 1 million microscopic internal pathways. Forcing a massive blood volume into these microscopic pathways creates an intense, artificial high-pressure environment within the organ. This pressurized environment allows the kidney's microscopic filtering units to begin their work. Each kidney contains over 1 million microscopic filtering units called nephrons, which begin at a structure called the glomerulus. Acting as a high-pressure sieve, the glomerulus squeezes water, waste, and nutrients out of the capillaries, trapping blood cells inside. Downstream in the renal tubule, the kidney selectively pulls 99% of water, glucose, and minerals back into the bloodstream. Only the concentrated urea, creatinine, and excess fluid remain to drain down the ureter as urine. This cycle of expulsion and recovery relies on a stable pressure environment to function. Because nephrons rely on high pressure, they are fragile when flow is obstructed or when pressure fluctuates. Kidney stones are a failure of obstruction. Poor hydration allows calcium and oxalate to crystallize and block the flow of urine. This blockage causes pressure to back up into the kidney tissue, resulting in excruciating pain. Hypertension acts as a mechanical failure. In this visualization, high-pressure blood waves impact the delicate vessels of the glomerulus. The vessels eventually scar, stiffen, and lose their ability to purify blood. These conditions represent a mechanical breakdown of the body's internal plumbing. Protecting your kidneys requires daily habits that manage internal flow and systemic pressure. Water intake maintains fluid volume to continuously flush out minerals before they can crystallize. Reducing sodium lowers systemic blood pressure, sparing the nephrons from high-pressure impacts. Over-the-counter NSAIDs can chemically constrict arteries and reduce blood flow to the organ. Treating this high-pressure plant with care keeps your body chemically balanced and toxin-free.